Okay, here we are again. Somebody in the YouTube comments asked for, well, a couple different people asked for, one, information on how the Speeduino is wired up to run the K24 in my Insight. And the second one was, what are the base settings that I'm using to get the car to run in Tuner Studio. So I want to take this time to just briefly go through my wiring diagram here. I'll hold it steady for a minute so you can pause the video and hopefully see how things are connected here. I'm just going to go through each sensor and talk about what each one needs and which sensors are needed and which ones are not needed. It's not terribly difficult to figure out, but if you're new to this, it's probably a little much. So I'm gonna just talk through this quick and well, quick, maybe quick. We'll see how long it takes. First, I'll do the wiring diagram, and then I'll show you a few different things on software setup. Okay, so what I've got here is this is the wiring diagram for basically all the wires related to the engine in the car. If you remember, I took my engine is a K24 A4, which would be like from a 03 to 05 Honda Accord. It's very similar, at least from a wiring standpoint, to a K24 A2 from a TSX. The difference being, I think that all the TSXs were drive-by-wire, and the Accord in the years that I mentioned is drive-by cable, which is what I wanted because I don't need any extra complication. You can see I've got enough stuff going on here already. So what I've got here is, I think I've kind of waved my hands at this before, but I want to give you a little more information to maybe help you out. So what I've got here is on the left side, all of the basically pins at the ECU, which used to be the transmission control module, but I gutted it and I'm using the plugs here. So I spliced the Accord engine harness that was all chopped up when I got it into the plugs for the original Insight transmission control unit and used the OEM plugs, and then had jumpers inside the ECU to make it all work between the Speeduino board and the connectors here on the ECU. So it looks pretty finished when you have the lid on the ECU, but it's kind of a Frankenstein. But if anybody, if I ever sell the car, I'm not too worried about people not being able to figure out what's what, because I have everything documented on this drawing. So what I'd like to do is first, let's talk through what sensors and inputs and outputs I've got connected. The map sensor, I have that connected. I have that connected. The throttle position sensor, I have that connected. Intake air temperature, I have that connected. Engine coolant temperature, I have that connected. You can run it with or without the idle air control valve. I do have that connected. You absolutely need the crank position sensor, which is CKP and Honda speak. For the way that I've got it set up right now, you do not need I think this is intake and this is exhaust cam position sensors. It's not supported in the Speeduino decoders, so there's nothing you need to do with those if you just want to get the car running. EGR position is not wired up. EGR is not wired up either. I'm not using that in my application. Let's go here. You don't need vehicle speed sensor. I do have that wired up only because it needs to go to the cluster. It doesn't, the ECU, the Speeduino ECU does not need it. There is an input for it. I don't think that so it's March of 2022, there's not any traction control or really anything that you can do with the VSS input, so I haven't wired that into the ECU yet. You do need all 4 of your fuel injectors. obviously. The knock sensor is not wired because Speeduino does not support it. You need all four of your ignition coils. You do not need your VTEC pressure switch. I'm sure you could come up with some sort of interlock circuit so that you can't get into VTEC without sufficient oil pressure. I think that I heard that the D-Series stuff from overseas does not use a VTEC pressure switch. I'm not terribly concerned about it because I have the VTEC solenoid wired up just to trigger on RPM basically. So it's, I think I've got it set at 3,500 RPM right now. Remember, this is a two-lobe VTEC, so the VTEC E setup from the Accord is what I'm running. So VTEC is lower than you might think of it in a performance VTEC car. And then the VTC solenoid, I do have that wired. Actually, I don't have that wired. I have the input wired to a pin on the ECU, but I'm not using VTC. So I've got what I did is I advanced the cam gear one tooth on the intake, just so it's closer to center line when it's running, and I just leave it in one spot. I'd like to get VTC working. It's not going to be terribly difficult to do, but with the stock trigger wheels, you're probably better off not trying to use it. You can use it open loop. You're going to have to do some research to figure out what pulse width equates to what VTC angle, and you almost have to have a dyno and some way to see your cam angle with respect to crank angle, and it just sounds like a whole ball of wax that I don't want to mess with right now. So what I'm planning to do, and I'll talk about this later, is to get VTC working, which I think is going to be it's been pretty well proven that it helps you with mid-range power. I'm going to modify the trigger wheels, but I'm going to talk about using stock trigger wheels right now and kind of go through this piece by piece. So let's talk about what each sensor needs to make it work, and there you go. So the map sensor here has a 5-volt reference, which comes out of the Speeduino ECU. It has a signal that goes back to the ECU, and a signal ground that goes back and ties into the ground at the ECU. So that's all that's going on with the map sensor. I am using the original Honda map sensor, not the what would you call it, the external sensor, which would be mounted inside the Speeduino on the board. I'm not using that because I think it was back ordered when I went to order it, and I already have a map sensor, so why would I spend money on that? TPS has a 5-volt reference from the ECU, a signal, and a sensor ground. So same kind of setup. You just got to make sure the signal wire gets back to the correct point in the ECU. The IET is really simple, and same with the ECT. You give it a 5-volt reference out of the ECU, and the sensor actually works by varying resistance based on temperature. So it varies how much voltage is dropped across here, and then there's another resistor in the ECU that's on the board that is pre-selected that you get this temperature out of there. So the way these work are they're higher resistance when it's cold and lower resistance when it's warm, at least both of these Honda sensors here. ECT, like I said, same thing, 5-volt, and then the signal coming back. The IEC has a ground that goes to the top of the intake manifold, and has a positive 12 volt signal or a 12 volt power supply from somewhere in the car, fused hopefully, and then black and red signal wire going back for this particular car. And then this is probably the most, you could probably get it to run with a lot of the other sensors either faked or not working, but this is, the crank position is the absolute key to getting this to run. So you put a 12 volt signal in, you put the ground to the top of the intake or somewhere on the engine block, and then there's a signal wire coming back. So there's actually pulses each time the trigger wheel goes past this sensor that go back to the ECU, and it uses that to calculate RPM and crank position and all that fun stuff. Like I said, I'm going to modify the trigger wheels. I do have both of these wired back to the ECU connector, but they're not jumpered inside the ECU. So probably what I'm going to do is modify the intake cam trigger wheel and see if I can get it to run closed loop VTC. We'll see how that all works. I'm running a flex fuel sensor, which is just a GM flex fuel sensor off of like a Regal or Equinox, something like that. That's just three wires. It gets a 12 volt, it gets a ground, and then it gets and then the signal, which is just I think it's a frequency pulse width. Yeah, I think it gives you 50 hertz at 0% ethanol, and then 100 hertz. It's something like that at 100% ethanol. So that's how, when I start running it on ethanol, I'll be able to use that sensor. All right, so going back here to the injectors. Injectors are fairly simple to wire in. With the Speeduino, you got to remember that the Speeduino does not, sorry, I got my finger in front of it. The Speeduino does not compensate for your firing order, so you have to wire in the firing order. The Speeduino fires the injectors and the coils sequentially, so it always fires them 1, 2, 3, 4. So you have to wire up your 1, 3, 4, 2 firing order into the ECU correctly, so that it fires. See if I can do this. I can't do this by memory, but you need to make sure you get your sequence correct. Otherwise, you could actually swap two of these with the way that it's set up now, and it wouldn't make any difference because it's semi-sequential, which means that the injectors fire in pairs, and I'll talk about that when I start talking about the trigger wheels and stuff. The ignition coils are fairly simple. There's a ground, there's a 12, I believe there's a 12 volt supply to them, and then there's I apologize. There's a 12 volt supply to them, and then there's a one signal for each coil going back to the ECU. And that tells these smart coils when to fire, basically, by pulsing that input. So, or output, I guess, from the ECU standpoint. Okay. So again, keep in mind the Speeduino fires its coils 1, 2, 3, 4 on the outputs. You need to make sure you have it wired up correctly. So let's do this quick. So the Speeduino fires ignition 1, 2, 3, 4, but your firing order is 1, 3, 4, 2. So you need to wire 1 to 1, 3 to 2, 4 to 3, and 2 to 4. So this is Speeduino outputs, and this is we'll say physical wiring. Okay, so you need to wire them up like that. Does that make sense? Ask a question and I'll talk about it more if you don't understand. Okay, so VTech Solenoid, that is a pretty decently beefy solenoid, and you can't drive that directly with the output of the Speeduino. So you either need to have a like I've got a ULN 2003 or a a relay to do that. Actually, you can't even drive the relay with the setup that's in there. So I've actually got a ULN 2003 wired up to trigger my VTech relay here, we'll call it. So the ULN is inside the ECU, and then I'm using this to actually trigger it. So it's just an on-off. I think I just stole the air conditioner compressor relay out of my Insight, and then used some spade terminals to make that work. I think that what I want to do when I run VTC is I'm going to take that ULN output and connect it directly to the VTC. So right now I'm running the VVT control, is what it's called in Speeduino, directly to the directly to run the relay to turn the VTech solenoid on and off at a specific RPM. So it's just on off. When I reconfigure this, I'm going to set up the nitrous output to turn on VTech, so just you're on and off, and then I'm going to rework it so that the VVT output is what they call it, which is VTC in Honda speak, can run the VTC solenoid. So I'll see if that's going to work when I get to that point. And then over here, I've got a wideband O2 sensor. I've got a VSS and TAC converter that a guy named, I think, Brandon Marshall on Facebook shared with the community, and I made a version of that. It's messed up, so I need to fix it, but all the wires are there for that. And this is basically just to drive the Insight cluster. So if you're doing some other Honda that uses the K series stuff natively, it's not a big deal, or you're using different gauges. And then wideband, what else did I have here? I am going to have the clutch switch wired up. Let's see what else I've got here. I've got the cooling fan relay connected up to Speeduino, so the Speeduino can turn the fan on and off based on engine temperature, coolant temperature. And I've got the fuel relay wired up to the Speeduino ECU2, so when you turn on the ignition, it'll pulse prime the fuel system by running the pump for 2 seconds, and then it holds the relay in while the engine's running. So it kind of acts like an OEM setup, basically. Let's see what we got here. Fan, key interlock. Nice. You probably don't care too much about all that stuff. We'll just show this so that you can see what everything is. Okay, so that's the first part. And then I've got this set up here. So there's a 40-pin header inside the Speeduino with all of the outputs and inputs. And I've got it mapped to my ECU connectors. Now this won't mean anything to you, but it just gives you an idea how I've done it. And then basically each one of these is a jumper wire inside the ECU between the ECU header and the connector on the outside of the ECU case, if that makes sense. So just showing you kind of what this is and how it works. I guess that's all I have for this part. I will talk about the setup and that kind of thing next. Let's get this set up quick. Bear with me here. Let's cut this part out, maybe. want to show some resources that I've got pulled up here that'll show you where we're at here. So first place to start with anything you're doing Speeduino wise is the Speeduino manual, which is wiki.speeduino.com, and they've got all these topics over here. They've even got system diagram to show you how all your options on how to connect things. Injector wiring, they talk about that. So start here. Your life will be much better. So trigger patterns, decoders. You saw I already had the Honda D17 up. So this is what you're going to use for a K series. They really should update this because I don't think there's many guys wanting to run a D17 on Speeduino, but there probably are some guys that are interested in running a K on it. So, alright. The decoder uses a 12+1 crankshaft wheel, which I'll show you what that looks like. Oops, that's not the one. It looks like this. So it's got, this goes behind the harmonic balancer inside the timing cover, and it's got 12 teeth around the outside evenly spaced, and then it's got this one right here that's the basically tells the ECU, it looks for the spaces and counts it, and then when it finds a short duration pulse between the two here, it knows that it's at a specific crank angle. And so the way that the Honda D17 decoder works, and here you can see, it gives you pulse, and then it gives you two close together, and then it says, oh, that one's tooth one after that. Which for the D17, I think they're phased differently because I have a different offset than they use here. So all you need is the crank signal, and you can run the engine with all these other things. So the only thing that's really unique here to any other engine is finding the values and all that kind of fun stuff. So the 12+1 crankshaft, and the D17 apparently uses a 4+1 camshaft signal. I'll show you what we got here. This is the two cam phaser, or the two cam trigger wheels off of the back of a K series. So here's the exhaust. Here's the intake. You've got 1, 2, 3, 4 tabs on there. So the sensor would sit kind of like this, and as this spins, it gives you pulses off of these. The exhaust cam gives you 1, 2, 3, 4, and a little fifth one. So the stock ECU can use these to calculate, where top dead center is, and where the there we go, and where the intake cam is at any given point. The intake so it uses VTC to look at those. So that's those. That's that. So going back here, the only real drawback here is because you have a how do I want to say this? Because you have only a crank signal that's compatible with Speeduino when you use this D17 code decoder. You can't run sequential, so you can't. Basically, you have to fire. How do I want to say this? Basically, you've got RPM, and you've got your ECU will know that you're at top dead center on the number one cylinder, but it won't know if you're on the compression stroke or the exhaust stroke. So, in order to run, it needs to basically fire the injectors in pairs and the coils in pairs to make sure that it's hitting the hitting the on compression stroke TDC on each cylinder. I don't know if that makes sense. You can do some more research on wasted spark. So I'm running semi-sequential, which is injectors paired So they are wired individually, but they're paired in the software. So, you know, if you have, say, cylinder 1 and cylinder 4, I think that's how they're paired, yeah. So cylinder 1 and cylinder 4 will be at top dead center at any given point, and then one of them is going to be on the compression stroke, and one of them is on the exhaust, exhaust stroke. So you've got an exhaust valve open on one. So by injecting on the compression stroke of number 1 and the exhaust stroke of number 4, you're injecting against the open valve for 1 and the closed intake valve for 4, and you're sparking basically a closed on the power stroke, on the top dead center compression stroke for cylinder 1, and then cylinder 4 is just, there's no charge in there. You just ran a cycle, so unless you've got a crazy rich mixture or something, it's just gonna spark the spark plug and not do anything because it's on the exhaust stroke basically. So that's that. Now I can show you the Tuner Studio stuff and how I've got things set up here. And I didn't really rehearse this, so if it's not perfect, I apologize. Hopefully you don't mind listening to me ramble. Okay. This is the wrong setting. Let me make sure it's the correct setting. Alright. D17. Okay. So here's how I have the trigger settings on my car that runs currently. Honda D17, you can't really do anything with that decoder except, it's all in there already to use that 12+1 setting. I've got a trigger angle of 70 degrees in mine. I think I'm actually using the falling edge. I'd have to check this. Anyways, rising edge, whatever, doesn't matter. You can use rising or falling edge. I think I must have it on rising edge. Skip revolutions, this is how long it waits to start firing the injectors and the coils as you're cranking. So it wants to see two revolutions. My car actually has issues with starter kickback, and I think that's partly due to this setting being too low. I need to work on that some more. Trigger filters on medium. So there's not much to set up for this. However, you'd probably be interested in so you can calibrate your TPS by just pushing the pedal down. So you just do get current when you have it online, and then you push the gas all the way down and get current, and then that scales your throttle position right here. So that's pretty easy. That's the wrong one. Tools. Okay, calibrate pressure sensors. This one might be interesting to you. Okay, here's what I've got in there for the stock map sensor. -4 and 79. This seems to read about 3 kPa low, so I would work with those a little bit more, but the scaling seems good. There's just a weird offset in there that needs to be worked out. So I would change this to -1 and 182, and that should get you right where you need to be. Temperature sensors. So the temperature sensors, the coolant temp, and the air temp, use the Bosch NTC, I think, curve. So you literally will just pick this from the pull down menu, the Saab Bosch, and that's the correct scaling for the Honda engine coolant temp and intake air temp, and that seems to work great. Let's see if okay, so that's really all I've got to show you that's specific to my installation right now. Hopefully that helps someone. like I said, this is still in development, but it does show you how to get running on Speeduino, and you know, it's been a lot of work to get it to this point, to find all the values and scale all the sensors and stuff. A lot of that stuff isn't published because everyone just runs a K-Pro, which is fine, but this is a lot more cost effective. Let me talk about my my modified trigger wheels. So what I'm planning to do, let's get in here, trigger setup. So what I'm planning to do is I'm going to run a dual wheel is what my plan is. So I'm going to have a 12 tooth wheel, so I'll show you this. That's not the right one. Here we go. This one? No. This one. So I'm going to use my 12 tooth wheel, so I'm going to grind this tooth right here off. So it's just going to have 12 equally spaced teeth, and then I'm going to run rising, that's fine. I'm going to take, go back here again. I'm going to take both of these actually, just since I'm going to be doing it. So here's the exhaust. So I'm going to take the intake. Let's get this going. Here we go. So I'm going to take the intake wheel and I'm going to grind off 3 of these. And I'm going to have a single tooth for the intake wheel. I'm going to only use one of these at a time. So my plan is to try to get the VVT working, to use to run off of the intake wheel. And then as a backup, I'm probably going to take 4 of these off and leave one here in case I can't get it working with VVT over here with the angle changing. I can just plug it into the exhaust and it should work, at least open loop. So that's my plan. I also found another resource that was useful. This is the Haltech Support site on the Honda K series engine. It gives you a bunch of stuff that might be useful to you. It talks about, these are all K20 things, but it gives you a bunch of information here. And if you just search for, let's see what I searched for, Haltech K20, it's one of the first ones here. And basically tells you how to get the K series to run with a Haltech system. See, it's things like injector dead time and all that kind of stuff. It actually gives you some VTEC control parameters too, which is kind of nice. So you can use this as a reference just to, you know, even if you have an RSX, it's got all the 02 to 04 RSX wiring diagrams in there, which might be useful. So this was a resource that I used to find out what the coil settings needed to be, and you know, what voltage you needed to run the crank position sensor and all that kind of fun stuff. So that's an overview of how I've got things set up right now. I'll give you an update on how the rest of the stuff turns out as I find it. So thanks, bye.